Bismillahirrahmanirrahim. Assalamu alaikum. Okay, guys, in this video, we are going to talk about the access lists. And first of all, for the short form, I would like to use ACL instead of the whole word access list. So, talking about the ACLs, there are two type of ACLs: standard and extended. The standard ACL uses the IP address of the packet, and it will either allow or deny the access using that IP address. It can be IP address of a particular host, or it can be the IP address of the entire network, depending upon the configuration. If you say that please allow or deny the access for this host or for this network, that entire network or that entire or that is given host will be allowed or denied from the access. Similarly, on the extended access list are able to examine the headers of the packets, so they are able to distinguish between their packet types. So in the extended access list, you are able to basically deny or allow the particular type of traffic or particular type of packet. So in extended ACL, if you say that please deny only ICMP packets, which are ping packets, it will only deny the ping packets, and it will allow other kind of packets which will be of telnet, or which can be of HTTP, or which can be of SNMP. Similarly, in extended ACL, if you say please deny the telnet and allow other traffic, so that will only deny the telnet traffic from the given host or from the given network to the given host or to the given network. Basically, standard access list will only use the IP address of the host or of the source, or basically of the source network or of the source host. But the extended ACL is able to use both the source and the destination, and it is able to distinguish between packets. It is able to block or deny the entire network or the given host from access to the destination host or to the destination network. That is, the extended ACL is able to use that source addresses and the destination addresses as well. But standard ACL will use only the source address, which will be either of the network or of the given host. So let's see how can we apply the access list. Basically, there are two methods to apply ACL. You can apply ACL on any interface of a router, but that depends on your need. If you want to configure the access list on this interface, or on this interface, or this one, or this one, or this one, or this interface. Basically, when we are configuring standard access list, you will see that your traffic will flow from this network to the router 1. For this interface, the packets will be incoming from this network. If let's suppose that if I am pinging from C1 to C4, the first packet will flow from here switch to switch 1, and then from switch 1 to R1, then R1 to R2, then R2 to R3, then from R3 it will move towards R4. So that means the packet is going from here to R1, and on this interface the packet is incoming, and the same packet is outgoing from this interface. Similarly, that packet is incoming on this interface. Similarly, that packet is outgoing on this interface, incoming on this interface, outgoing from this interface, and finally coming to the destination, or incoming to the destination. So access lists are able to examine the incoming traffic or outgoing traffic from the interface. If you configure the access list on this interface and you want to block this network, you will configure this access list to examine the incoming traffic on this interface. That is, you will say, when we are configuring the access list, you will say IP access group, and then inbound traffic. Basically, you will say, you will ask the access list to examine the incoming traffic. Similarly, if you want to configure the same access list on this interface, you will say please examine the outgoing traffic. Or if you are configuring on this interface, you will say please examine the incoming traffic. Or if you are configuring the access list on this interface, you will say please examine the outgoing traffic. So there are now possibilities here, 1 2 3 4 5 and 6 interfaces on which we can apply the access list for this network to block this network, this whole network, from accessing this network. So where should we apply that? If we are using the standard access list, it is to be noted that a standard access list should be applied as closest to the destination. Why? Because if you apply the standard access list here, or on this interface, or on this interface, or even on this interface, it is going to block communication. Let's say that let's suppose that you have applied the access list here. So the packets will move from here, R1 will towards R1, and then from R1 to R2, and then when incoming on this interface, they will be blocked. So this network will not be able to communicate with this network, whereas you do not want to you do not want to block this access. You only want to block the access from here. You do not want this network to access this network, but it should be able to communicate, or it should be able to send packets to this network. So if you apply the access list, standard access list here, it will block all kind of traffic here on this interface or on this network, and your packets will be discarded, and it will not be able to reach this network. So that's why you will not apply the access list here. And then, talking about this, on for the current configuration, if you apply the access list here, it is uh, it is okay to apply the access list here, so that it will block this whole network. But let's suppose that you have another network here which is connected here. Let's suppose you have another interface, and you do not want to block that access as well. So for that, you will only apply the standard access list here, so that the traffic should be able to move from R1 to R2, and from R2 to R3, and from R3 to any other network here or here, connected to the other interfaces which are not currently present. Only the interface here should block the traffic from outgoing to this network. So standard access list is basically applied as closest to the destination, so that other networks are not denied or allowed the permission. Similarly, for the extended access list, you should basically apply the extended access list as closest to the source, or as closest to the originating network or originating host. Because let's suppose we are talking about this C4, and you want to block the telnet access to this host or to this network, and your traffic will move from here, from R1 to R2, then from R3, and from R3, when going to C4, it will be discarded here. The telnet traffic will be discarded here. But what is the use of making flow the traffic here and then here? It is of no use. So let's deny the traffic directly here, so that the traffic should not flow here and here. Basically, it is of no use to let the traffic flow on all the networks, through all the networks, and then deny at the end. If you want to deny the traffic, let's deny in the very start, because only the specific kind of traffic is denied in the extended access list, or you can allow the specific kind of traffic. So extended access list will be it is preferred to apply the extended ACL nearest to the source, or nearest to the originating host or network. And similarly, the standard ACL is preferred to apply as closest to the destination, or on the last interface which is going to the destination. So let's apply the ACLs here. Before that, I'm going to tell you the IP addresses present. This is 192.168.10.0 network. This is 10.1, 10.2 and 10.3. Similarly, this network is 192.168.20.0, and 20.1 is this interface, and 20.2 is this interface. Similarly, this network is 192.168.30.0, and 30.1 is this interface, and 30.2 is this host. And this network is 10.1.0 and 10.1.0.1 and 10.1.0.2 is this host, this interface. And this network is 10.1.0.5, and .6 and .7 are these interfaces basically. sorry, 10.1.0.4 is this network, and 0.5 is this host, and 0.6 is this interface and this interface, 0.5 and 0.6. So let's apply the ACL. First of all, I'm going to apply the standard ACL here in R2. So there are two methods, two ways to basically configure the access list. You can configure the access list directly or by going in the configuration mode. Let first of all move into the config t terminal. Now there are two methods. I can say access, I'm using the first method now, IP access list, and then I will give the name standard or extended. So let first of all we are going to apply the standard access list, standard, and the number here. The standard access list has number from 1 to 99, so you can use any number. Let's say we are using 10 here, and then press enter. So I am in the configuration mode of the IP access list standard. Now you can see the config std and NACL. So basically this is standard ACL. Or there is one more method. Now I can use permit or deny, and then I will say the network address which I'm going to deny the access, 192.168.10.0. and then let's see here, I have to give the wildcard mask here. So it is asking me wildcard bits. So wildcards is 0.0.0.255, which means that the 0.0.0 means that 3 octets will be matched entirely, and for this octet, for the last octet, 255 means all the hosts, so that means the entire network will be blocked. Deny this, and then in the end I will say permit any. Why am I using permit any? Because in the end of all access list there is one command, deny all. So if I do not if I don't use permit any, and if I don't use permit IP any on the extended access list, it will basically deny all kind of traffics. So I do not want to deny all kind of traffics. I'm only denying this network here. But if there is another network on R1 which is connected to R1, and if it is trying to move from R1 to R2 and from R2 to R3, it will allow that network. So that's why I have to use permit any or permit IP any, basically, for not permit IP any but permit any only. Permit IP any is used in extended access list. Basically, permit IP any that is used in extended access list. So this is the standard access list configured here, and now I will exit this, and now I can apply the access list on the interface. So I'm going to go into the interface. Now see here, if I want to deny the traffic here, E10, so interface E10, and then I should say IP access group, and then I should say 10, which is the access list number which I configured here. IP access group is the command. Then you will give the number of the access list you have configured, and then you will say out or in. Why out or in? Now see here, in or out. In is for inbound packets, out is for outbound packets. So out will examine the outbound packets, and in will examine the inbound packets. Now see here, for this interface, the network here, the packets originating from this network will be basically incoming to this interface. So I will configure in. I will say in here, because if I say out here, so the packets moving from this network or moving from this network towards this network will be examined. But instead I want to examine the packets moving from here to here or here. So on this interface, the packets originating from these hosts are incoming, so I will say in here, in. Now the access list has been applied. Let's try pinging the hosts from PC1. Let's try to ping the C3. Ping 192.168.20.2. Now see, you can see communication administratively prohibited. It is not able to ping this host because the access list is denying the packets right on this interface. Let's configure the access list again. I will say no IP access group 10 in. The access list has been removed, and let's let's configure the access list using out. Now using out, I will be able to ping the network, ping the host, because why the packets are able to move from here to here, because the access list is applied on this network, on this interface, basically E10, but it is examining only the outgoing packets. It is not examining incoming packets. So these packets originating, the packets, ping packets originating from this network, are incoming to this interface, and it is not going to scan incoming packets, because I have said please examine the outbound packets. So that means that incoming and outgoing packets are you if you want to examine the incoming packets or outgoing packets, that depends on your need. Where do you want to block the traffic, and how your traffic will be flowing, and how your traffic you want to block. So I am again removing the access list here, IP access group 10 out. So I am saying no IP access group 10 out. So we saw that applying the access list here on this interface is blocking me this host as well, which I do not want. I only want to block this host. So let's apply that access list here. I'm going to move towards the interface E11, I guess. E11. Yes. E11, and I will say IP access group 10. And then now for this interface, the the examining should be done on outgoing packets, because the packets will move from here to R1, from R1 to R2, and R2, on this interface the packets will be outgoing. So I want to block the outgoing packets. So I will say out here, and now let's see here, ping 192.168.20.2. I will be able to ping this host because I'm pinging this host. I am able to ping this host, but I will not be able to ping this host. Let's see here, ping 192.168.30.2. Now you can see communication administratively prohibited. Now again, the drawback of applying the access list here or on this interface is that if there is any other network present here or here, or after that, after this interface, if I apply the access list here, there is some network present here, I will not be able to communicate with that network as well. So if I only want to block this network, I should apply the standard access list as closest to the destination. So I'm going to remove the access list from this from this router. No IP access group 10 out, and then I should exit this interface, and then I should say no access list 10, sorry, no access list 10. So the access list has been removed from this network, from this router. Now we are going to configure the access list on router 3. So coming on the router 3, now I will apply the access list on router 3, and I will block this network from accessing this host. So on router 3, config t, I am inside config t. Now I'm using the other method, access list 10, and then I will say deny 192.168.10.0.000.255, and then access list 10 permit any, and then on the interface E11. Why E11? Because this is E11, and IP access group 10, and then out. And why out? Because we know that the traffic will be flowing from this whole network towards this, and then from R2 to R3, and on this interface the packets will be outgoing. So we want to block the outgoing packets. So I'm saying out here, and then let's try pinging the network 192. 192.168.30.2, and now we can see communication administratively prohibited, and that means that the access has been blocked, but we are able to communicate with this host, with this network, and even we will be able to communicate with this interface as well, because the access list is only applied here and not here. Let's try pinging this host, if we are able to ping that host or not. 192.168.30.1, we are able to ping that host as well. We are able to ping this host as well, this interface as well of the router, but only the final outgoing packets from this interface will be blocked. So that means the standard access list should always be applied as closest to the destination. So now we shall configure the extended ACL. Let's say that we want to block this network here, but the specific kind of traffic, which is telnet or ICMP, for this network. So if we are using extended ACL, we should block the traffic directly here, we should block the packets here directly. So on router 1 I will configure the extended ACL, config T, and then I will say IP access list extended. Then I can give any number from 100 to 199, or I can give the name as well, which will be named access list, and press enter. Let's say deny. Now you will see there are different type of traffic or packets which we can deny or allow: TCP packets or IP packets or ICMP packets. So let's say deny ICMP here, which is ICMP we can check, but if I say TCP here and I want to block the telnet traffic, let's first try the ICMP, deny ICMP, and then see here it is asking me source address. The source address will be 192.168.10.0.000.255. This is going to block this whole network with this wildcard mask. If I say 192.168.10.2 and I will say 0000, so this is going to block this host specifically, but not the other host. 10.1 will be allowed, 10.3 will be allowed, only 10.2 will be blocked because the wildcard is 0000. So if you want to block a specific host, you can give the specific host address with wildcard mask 0000, or you can also use the keyword host and then say 192.168.10.2 here. So this will also do the same thing as giving the 0000 wildcard mask. So 192.168.10.0, and if I'm going 000255, so this will block this whole network basically. So 1000255, and then the destination address you can see 192.168. destination can be any, because I want to block I want to deny the any destination. I want to deny ICMP packets for any destination. So I'm using the keyword any, or I can also give again host, and then I can say that please deny the traffic meant for this host only but not the others. So I can say host and then give the specific host address for which the ICMP packets will be blocked, or again I can say 192.168.30.2 and then give 0000. So this will again do the same thing, because 000 wildcard mask means 30.2. This address will be exactly matched, and 30.2 is this host. So whatever the packets move from this network, they will be examined here by extended ACL, and if the ICMP packet is only meant for this host, it will be blocked. But if it is meant for this host or any other host in this network as well, only this 30.2 host will be denied the access, but the other networks or other host will be allowed. So if I'm saying this here, let's try that, and permit IP any. Why am I using permit IP any? Then because the same thing, in the end there is deny all. So I do not want to deny other kind of traffic, so that's why I have to use permit IP any, so that it should allow any kind of IP packets, and from any from any source, and from any and for any destination. So permit IP any, exit, and then I will move towards the interface E11. I guess it is E11. Let's see, confirm here. E11, yes. And IP access group 10, not 10 but 1110. And then what should be in or out? It should be in, because the packets will moving from the packets generated from C1 or C2 will be incoming to this interface. So I will say in here, and now I will try pinging the host 192.168.30.2. It is administratively prohibited because of the access list, and but let's try pinging the other 192.168.30.1. It is able to ping this interface. It is not able to ping this because this has IP address 30.2. Similarly, if I say ping 192.168.20.2, it is also able to ping this host. So that means that extended ACL is only blocking the ICMP packets, which are ping packets on this interface on E11 of R1, and they are incoming packets on E11, and only the packets meant for C4, which is 30.2, only the packets meant for 30.2 host ICMP packets, only those ICMP packets will be blocked, but all other kind of traffic and all other kind of packets meant for any other host or meant for any other network will be allowed. Even the telnet traffic or HTTP traffic or SMTP traffic will be allowed. Only ICMP packets are going to be blocked for this host using extended ACL. So this is how you configure extended ACL. Let's try one more thing here. Moving towards IP access list 1110, no, extended 1110, and then I will say deny. Let's try TCP 192.168.10.0, or let's say 192.168.10.2.0.000, then 192.168.30. Let's say 20.2, and then say 0000. And now you will see there is, I I wrote question mark here for help, and you will see different kind of arguments which you can use. So EQ match only packets on a given port number. So extended ACL is also able to use port numbers, so we can use EQ. And then for port numbers, 23 is the telnet port number, or 25 is SMTP, or 80 is HTTP. So for telnet we are going to use 23. I will share the list of TCP and UDP port numbers, and you can see different kind of port numbers here. See here, 23 is telnet, 20 and 21 are FTP, and similarly 80 is HTTP, 80 are HTTP basically, and similarly other kind of packets as well, other kind of port numbers. So we are only blocking this EQ23, which is a telnet traffic. So this command, what is this doing? 10.2 is the source, and this will be matched exactly. That means that 10.0 network is not blocked, but only the 10.2 host is blocked, and meant for the meant for the destination 20.2. Only the 20.2 packets, only the packets meant for 20.2 host, because this is 000 again, and only the packets of 23 port number, which will be of telnet. So this means that this will deny telnet packets of source 10.2 moving towards 20.2. And then I will say permit IP any, and then I can apply the access list again, interface E11, and IP access group 1110 and then in, because I want to examine the incoming packets on the interface. And now this is configured, so only the telnet traffic is blocked, which is meant for this host and which is originating from this host. This command could be, this whole command could be applied using IP access list 1110, sorry, extended 1110. I could also say deny TCP host 192.168.10.2 and then host 192.168.20.2 and then EQ23. This whole is exactly the same with this command, because 0000 or use the keyword host instead of giving the wildcard mask. So these two commands will do the same thing. Similarly, let's try applying the extended ACL on router 2. We should try to block this host by we should try to block the only ICMP packets. We should try to block the ping packets from this host meant for this host, but not this. So that means C3 should be able to ping C1, but it should not be able to ping C2. And we should apply the extended ACL on this interface, which is E12 of R2. So let's try that. Config T and say here IP access list, and let's give the name instead of a number, so say my list, and then sorry, first of all given the keyword extended then my list, because the extended list can have the name as well. So deny ICMP 192.168, which is going to be the host. So I am going to say host 192.168.20.2 is the host which I'm going to block, and then now I'm going to give the destination address, destination host, which is 192.168.10.3, and enter permit IP any, and let's apply that access list on E13. E13 it is, or E12? E12. E12 and then IP access group and then say my list, and then it should be out or in. Let's see here, the packets will be moving towards this interface and they are incoming on this interface, so we should say in. Now let's try pinging this host using the PC3. From PC3 ping 192.168.20.10, sorry, 10.3. It is administratively prohibited. So that means that PC3 is not able to ping this, but it should be able to ping this, which is 10.2. So ping 192.168.10.2. It is able to ping this. So this is all for access list. You can practice different scenarios. You can build scenarios by yourself and you can practice on them. You can deny different type of traffic using extended ACL, and you can deny all kind of traffics using standard ACL. Important thing to remember is that on the whenever using standard or extended ACL, whichever of the ACL you are using, you should you should configure the specific kind of commands first and then the general commands later. Why? Because if you want to deny, let's suppose you want to deny this host, let's say the example of this R2 which we configured just now. We are saying deny this host by reaching this host, and only the ICMP packet should be blocked. But and then in the and then if I allow if I say permit IP any, if I say permit IP any in the first, and then I would say deny ICP MP host and this, so it will whenever the access list will be examining the packets, it will first see the line permit IP any, and it will simply allow this packet, these packets, this traffic, because this line is coming in the second. So that means the specific kind of denial or allowance should be done first, and then the general command should be used later, whatever the access list you are using, standard or extended. So that's all. Thank you.